apologize for anyone who's watching today. If you could bear with us.
Oh, there we go. Good job, Carol.
Hello. Yes, thanks very much. Good morning, good afternoon, and good evening. And welcome to the Industry 4.0 Club on LinkedIn Live. Thank you for taking the time from your busy day to join us today. This is the Women in Manufacturing, a weekly conversation on topics around I-40 with a focus on tech and manufacturing. It's a space to discuss the perspectives and challenges of women at work and at home. Our topic of discussion today is titled FibreOptics, the backbone of Industry 4.0. I'm Carol Mitchell-Lynn, an Industry 4.0 Club co-founder. For the last 5 years, I've been creating content for I-40 adoption in manufacturing. When I'm not supporting my fellow co-founders, I'm a content marketing specialist at Raven AI. First, I'd like to introduce my co-host and fellow Industry 4.0 Club co-founder, Grace Donovan.
Good morning, good afternoon. Thanks, everyone. Thank you, Carol, for that introduction. So I'm Grace Donovan. As Carol mentioned, I am her co-host of the Women in Manufacturing discussions, which we have here every Monday. And when I'm not joining you all here, I spend my time supporting small and medium manufacturers to adopt and implement connected technology to support the digital transformation and improve operational efficiency. So thank you so much.
Thanks, Grace. Today, we're excited to have as our special guest, Angela Thurman, Principal and Managing Director at Thurman Co., who I think, are you joining us from Houston today, Angela?
I am. Thank you.
Thanks. We really appreciate you taking the time to be with us today.
Thank you, Carol. It's my pleasure. And hello, Grace.
Before we start, Angela, let's break the ice a little bit for our audience and give them a chance to get to know you a little bit. If you could share with us what current projects you're working on and what makes you excited about what you're doing.
I'd be happy to. So thank you, Carol. So I'm the owner of Thurman Co., a woman-owned consulting firm here in Houston. And we work with manufacturers that are seeking program management and supplier risk solutions that typically they don't have in-house.
Great, thanks. Thanks very much. And I think people will appreciate what goes into that is a lot of work. Let's go to our first big question for you for today, Grace.
Yeah, so we'd love to know a little bit more about how you got your start in fiber and manufacturing and kind of how you came into this line of work.
Okay. So it all started in late 1993 when I started my career in telecommunications. My first job was with Williams Communications Group, which then was known as WillTel, in Tulsa, Oklahoma. So while I was at Williams, I held a number of different roles, including interLATA capacity planner, voice switch planner, network engineer, and eventually I was the supervisor of the engineering contracts group. So within all of those roles, to some degree, they provided me experiences to work with fiber optic networks, the equipment that's used to build and support those networks, the contracts and the contractors that are used to maintain the network, and then also how the contracts for the deals, the bandwidth deals were put together and how those were made. So while I was with Williams, I had the opportunity also to earn my Master of Science degree in telecommunications management, which was a unique program that was offered by Oklahoma State University in a satellite program there in Tulsa. But I eventually left Williams with a wealth of knowledge and experience and went to work for some other telecom companies, including Sprint.
Thank you. Yeah,
Sure.
I was just telling Carol kind of prior to, as we were preparing for this room, that my first introduction to fiber optics was the UFO lamps that were really popular in the 2000s. I wouldn't be surprised if maybe others in the audience had that introduction as well. So I'm really excited to continue to learn more about how this experience has played out throughout this discussion. So again, we're really
Yeah.
glad to have you here. Carol, over
Well,
to you. Oh, go
well,
ahead. Go ahead. I'm sorry. Go ahead.
prior to my experience with Williams, I actually worked for a manufacturing company that produced germanium tetrachloride, which is a chemical that's used in the cladding of fiber optic cable. So I didn't know that that would eventually come around in my career, but it was interesting as well.
It's almost like it was meant to be. And
It was. It was.
Fiber optics chose you.
Fiber optics chose me.
I think for myself as well, Angela, I grew up, my father worked for a company that manufactured fiber optics. So,
Oh, would that company start with a C?
no, it was a Canadian company.
Okay.
Maybe before we continue on this topic, for those who really don't have a full grasp of fiber, I kind of think it in general terms as, the movement of data and the volume of information that's moved along that. What do you think of that? And would you add to that? How would you add to that
So
description?
yeah, so fiber does address the vast amounts of data that is transferred or transported. But fiber is also the physical means of transporting that information and data. So it's the physical fiber optic cable. So think of it as similar to an electrical cable, a copper electrical cable. But instead of carrying electricity, a fiber optic cable carries light. And these cables are made up of minute strands of special glass. And each one of these fibers is smaller than a human hair. And then they're bundled around a more rigid core material that allows the cable to be both flexible and manageable, because this fiber optic cable could be pulled or pushed into its destination. So there has to be a certain amount of rigidity to maneuver the cable. So there are various layers of protective insulation around those strands of glass. And then this entire bundle is then further insulated, and it's finally wrapped with what we call a jacket for the final cover. And that jacket is color coded to indicate something about the properties of the cable inside. And the fiber optic cable can be either single mode or multi mode. So, single mode fiber is typically more expensive. And with single mode fiber, the light from a single pulse travels down the path of the fiber at the same time, and it arrives at its destination at the same time. So there's less dispersion or noise in that signal. So this is especially important for long distance transmission. So think of single mode long distance. And then the choice of what type of cable you're going to use is dependent on the application. So the designers, the engineers are going to take that into consideration when they're making their selection. So one of the things that makes the fiber optic cable different from an electrical cable is that it can carry many different frequencies at the same time. without interference. And that's one of the things that we call multimode. So in recent
Sorry,
technology.
could I just jump in here with a quick question?
Yes.
So to try and, I'm trying to, because I am very new to this topic, so I'm trying to kind of ground this from my own understanding, and maybe for those in the audience who might not have the same technical background as you. With the different frequencies of light, what I'm imagining too is like people on the receiving end, or on the receiving end of this light, ways to differentiate that light would be similar to what we see with a prism. So you get white, light, and then you have different outputs of different color. Would that be a correct way to kind of break down in layman's terms how that frequencies are differentiated so that data doesn't get totally muddled?
Yes. So now in reality, these frequencies are
Mm-hmm.
not in the visual spectrum.
Okay,
But
yes.
but to just put it in layman's terms,
Mm-hmm.
one way that we're increasing the bandwidth of this fiber is you've got equipment. One on one end is transmitting. I'm going to bring my hands up. Transmitting. The other end is receiving. So think of them as blinking. All right. So I'm blinking at this. This is me sending a signal. I'm blinking, and you're receiving. You're receiving my blinks. So the equipment has begun to blink faster and faster. Now it gets really complicated because not only am I blinking faster and faster, but my blinks are in different colors. So that's another way of adding more data because the receiver is receiving the blinks faster and faster and in different colors, different frequencies. So that's one way of adding more information in the signal. Does that make sense?
Absolutely. Thank you.
All right. So that so if the cable is then carrying different colors of light in the same fiber simultaneously, this greatly increases the bandwidth of the cable, or that the cable can support, which means more information is being transported. Any other questions on that?
I had a question. I know we didn't talk about this earlier, but when you're talking about the fiber optics, is that exactly the cable that's going in the ocean, underneath the ocean, or is that something different?
So nowadays, yes, transoceanic cables are fiber optic. Yes,
Okay.
it didn't used to be.
Thanks for clarifying that. I guess my next question for you, and I think it's something that people like to ask is how fast is
How
fiber?
fast? How fast is fiber? That is a really good question. So if we could go back to the comparison to electrical cables, coax in particular, a coax cable. Let me just go back another step. So think of the old-fashioned telephones in your homes. One telephone conversation. That was a 64 kilobit channel, one voice channel, 64 kilobits. The maximum that a coax cable can carry is it's called a digital signal 3. So 672 individual voice channels. So we get to optical. That would be the minimum. An optical channel would be the minimum of 672 voice channels. So fiber goes up from there depending on the equipment that is placed on the fiber. So what is it connecting? And then you have to think about, it's a little bit tricky, but there are a lot of different parameters that go into that. So are we talking about just standard or specialized cable? Are we using that wave division multiplexing, that different colors of light? or are we just using a single mode of white light? What is the distance involved? So if we take all of those things into account, here are some recently published speed results. So the Royal Melbourne Institute of Technology in 2020 published that they had used 160 WDM channels, a per channel speed of 244 gigabits per second for an effective speed of 29 terabits per second over a distance of 76 kilometers. Pardon me. So 29 terabits per second. Now, at the same time, the University College of London.
I'm sorry,
Pardon?
Angela. Yeah, I know. We're making you school us.
That's okay.
Take your time if you need to. If you need to take a break.
The University College of London at the same time transmitted 660 WDM channels with a per channel speed of 25 gigabits for an effective speed of 178 terabits. So compare 29 to 178 over a distance of 40 kilometers. Now, the highest that I was able to find was in Japan at the National Institute of Information and Communication. In last year, in 2021, using single mode, 4 cores, 552 WDM channels, a per channel speed of 144.5 gigabits for an effective speed, I'm sorry, this is not the highest, of 319 terabits, but over a distance of 3,000 kilometers. And the highest that I could find, again, a specialized cable, was KDDI Research in conjunction with Sumitomo, who is a cable producer. Single mode fiber, 19 cores, 739 WDM channels per core, 120 gigabits per channel, or an effective speed of 10.16 petabits per second. Now, a petabit, for those of you who may not know, is 10 to the 15th. So it is one step higher than a terabit. So that is incredibly fast. And that was over a distance of 11 kilometers.
So just to kind of jump in and this question came up as you were discussing like the varying levels of speed in different fibers. I'm curious if, looking to the future, this could create some bottlenecks. I'm kind of likening it to canals, and through this, through the supply chain, as ships have gotten progressively bigger and can carry more and more, ports have had to adapt and channels have had to widen. Do you foresee similar infrastructure challenges with fiber?
So with fiber, it's not the fiber that is limited. It's the technology of the equipment that is making the transmission. So,
all right. So that's where the updates are really going to need to come from.
And the life cycle of the fiber is generally 20 to 25 years. So, for example, you would put your fiber underground or wherever, but typically underground, and expect it to be there for 20 to 25 years. But you could update the equipment in your data centers or your points of presence whenever you want. So if you want to,
go ahead.
So as technology advances, it's not the fiber that you're going to pull out and replace, it's the switches.
Right. Well, that was precisely, I think, the point that I was leading towards. So thank you for finishing my own thought for me. Before we go on to the next question, I did have something, and this is not something that we've discussed, but I'm curious, kind of from a historical perspective of fiber. It's been around for quite a while. But I'm curious, what is the pervasiveness of fiber in North America today? I've seen, studies ranging from 43% to possibly even greater, depending on the date that the study was published. I'm curious, how prevalent is this technology currently, with your experience and knowledge?
Could you define that a little bit better? I mean, compared to what?
I guess compared to copper cables.
In a telecom network, or in a manufacturing environment, or?
I think I'm looking at it from like an overall perspective.
Mm-hmm.
I know they're different. So we have, government applications, we have telecom, and then we also have private businesses and internet providers as well. So, I think because I am new to this topic, I possibly kind of group them all together. So maybe that's why my question is coming across a little nebulous.
Okay. All right. So in a telecom network, you generally have three means of transportation. You have a copper network. I mean, you have copper, you have fiber, you have microwave. Copper coax has a maximum length. I mean, the signal will go 50 feet, and that's it. Fiber can go maximum, I think, is 50 kilometers before you need a repeater. And then microwave, I don't remember. I think it's about the same as fiber. I think it's about 50 kilometers before you need to repeat the signal. But so with coax, I mean, it's ubiquitous, but you have to think about what its purpose is. So, and of course, coax is not the only kind of electrical cable. I mean, we think of the old-fashioned telephone lines; those are made out of copper. But you have to think about where are companies going to put their investments too, because copper is very, very expensive compared to fiber optics. And that technology, again, think about how much information can you transport over copper compared to how much you can transport over fiber optics. The return on investment is just not there. So I think the infrastructure is definitely going to be in fiber optics going forward. And pretty much all of the major telecom companies have been building fiber optic networks for at least the last 30 years. So in the US, I would say it's everywhere, wherever there's a large population. And then you can go online and see their maps to see where the coverage is. Now, granted, in the mountainous West, so Utah, Wyoming, Idaho, you're not going to see a lot of fiber coverage there because there's not a large population there. And there are other regions of the US that are similar.
Yes, I saw a map from 2016, and what really surprised me was that there was not a single cable throughout South Dakota. I think there was one that maybe made it to the border, which was likely where, oh man, I'm going to Bismarck was located. Please correct me if I'm mixing up my capitals. But yes, it was, so because that map was in 2016, that's where I was curious, like from your knowledge, I'm sure it has increased since then, and that was like an internet provider map.
Right.
So yes, they can be different.
and then at that level, it becomes the responsibilities of the local, what used to be called the bell. So the local telephone companies will pick up the pace, and they'll have their fiber networks.
Yeah.
So and this is where we get into the local area, the local access transport areas, or LATAs. So that's where the large cellular companies or long distance companies begin to interact with the local access transport areas, and they connect their networks, and they rely on those local central offices to provide the extension of the network to the local communities.
Yeah, thanks. I think I remember years back, I'm from a rural community out in the mountainous West. And I remember when, we got the first fiber network to our community, and it was very exciting. We'd see them, on the highway laying that line. So,
big rolls of orange cable.
Yes. Lots of ditches along the highway.
Yes.
So yeah, I got to see that being implemented not all that long ago. But we do want to shift over to 5G, which is, so we kind of got there with telecommunications. You were discussing, how far those signals can go. But it is really becoming much more of a pervasive topic now that a lot of folks have 5G enabled phones, and it's now being discussed much more in depth in manufacturing and big data. So could you give us a little more context between the context and connection between fiber and 5G?
Certainly. So any cellular company is going to have a fiber optic backbone. I mean, that is the infrastructure of the network. The fiber will extend all the way to the cellular antenna. So 5G is the evolution of the telecommunications to the 5th generation. So that technology supports broadband, cellular networks. So that's going to allow you to have much faster uploading and downloading of your data. It'll support video on this device a lot faster of any type of information that you want right to the handset. So all those cell phones that are enabled with 5G will be able to connect to the internet and reach speeds of up to 10 gigabits probably, and that'll be supported within that cell. Any of the cellular networks, those base towers are called next generation node B, or GNBs. And these are all connected to the local telephone company's switch centers or central offices. And that's where your local access comes from. That local access is leased by your cellular network provider from the local telephone company. And that has to be purchased from that incumbent service provider. Again, formerly the Bell network. So from the tower back to the CO, from the CO back to your service provider's point of presence, or POP. And then that's where their own fiber backbone network begins. And so from their POP, they have a fiber optic network that connects their major markets. So you can, like I said, you can go and find the maps that can show their network nationwide, globally, whatever. So we're really only limited on the fiber is really only limited at the tower, and generally the fiber extends all the way to the antenna. So I would say The only portion of the cellular network that doesn't rely on fiber is from the antenna to your handset. That's where the radio waves come into play.
Yeah, that's an interesting way to visualize it. I mean, it is the way to visualize it, but I'm just kind of, building some images in my head of how that works. So, and I'm just thinking of all the different elements on a shop floor that will be using this technology, like autonomously guided vehicles, AR, VR, where you're having a lot of data coming over those airwaves, which is going to be critical for efficiencies and just where the industry is headed. So that's, yeah, it's really, I'm connecting so many dots today. So I really, really do appreciate you having you on today.
It really gave me, it was a bit of an eye opener to really get an idea of how cellular works and how reliant it is on the backbone. I really didn't know that. If it's okay, Angela, I'd like to take a few moments to give to reset, just in case somebody happened to join us ahead, and due to our technical difficulty, we lost our banner. So, so our nice Industry 4.0 banner, unfortunately, we won't be showing today. But this is the Industry 4.0 Club, for anyone who joined us late. And Grace and I are celebrating our inaugural LinkedIn Live with the Women in Manufacturing Room, normally run on Clubhouse, 12:30 Eastern Time every Monday. And today we're talking with Angela Thurman, Managing Principal and Managing Director of Thurman Co. And our topic for today is backbone of I-40 and fiber optics. Thanks again, Angela, for being with us today. And I guess we can move on. We're getting closer and closer. Our discussion's getting closer and closer to the manufacturing floor. And I guess the next part will be one step closer, and that's the installation of fiber and the contracts between the parties that get us one step closer to the manufacturer. And when I first met you, Angela, you pointed out some of the contractual limitations and challenges that can arise during fiber installation. And I really didn't appreciate the amount of moving parts that are related and all the stakeholders that really have to come to an agreement for this to really take place. And and so you really opened my eyes to that. And I'd like to know if you can share one of those use cases with us.
Okay, I'd be happy to. So one of the most blatant, I guess, contract problems that I encountered was when we had a buy-sell agreement where the sales team had arranged for my company to deliver bandwidth to services to the customer, and then in exchange, the other party would deliver services to us as well. So, so the part of the contract that defined where we would sell them services said, okay, the meet point or the connecting point is going to be in this piece of equipment in our POP, which is on the 9th floor of this building, which was in Chicago. And in telecom, there are these equipment panels where you plug your fiber in here and they plug their fiber in here and it connects and it's all nice and neat. Unfortunately, the customer side of the contract said, oh, the meet point is going to be in the manhole down in the street. And So sales had worked on this, legal had worked on this, and legally, these two contracts were completely fine. Unfortunately, from a technical perspective, that didn't work because the manhole's down in the street and our pop's up here on the 9th floor, and there's nothing in between to actually connect. So we had to work that out, and there were some difficulties because this was the city of Chicago. It was November. The city had issued a moratorium that said you can't do any work on the streets in the manholes until after the holiday shopping period has ended. And so we were being told you can't get a permit to do this work. And yet we had a very tight schedule, and if we didn't get this done, we were in jeopardy of missing some very important customer deliveries, and it was just not going well. It was not going to be good unless we could get this done. So after a lot of negotiations and some hard work, working with the authorities, we were able to get that permit. But then we had to get additional contractors, we had to get additional equipment, we had to physically pull fiber from the manhole to the 9th floor, make this connection, make it all work, expedite everything, so lots of fees, and get it all done during the holidays. So it was a learning experience for our attorneys and our sales team. And of course, I got to project manage the whole thing.
Blessing or a curse, but I think the moral of the story is, make sure that technical folks are involved early on.
Yes.
Avoid headaches like this in the future. As someone in sales, I'm taking this to heart.
It kind of sounds like supply chain for hardware.
Yes. Well, and that's another thing. At the time, as a project engineer, I would be responsible for receiving delivery of switches, and they had lots of different pieces of equipment on the BOM, right? And I had my switch vendor say, "Oh, well, it's just short a couple cables," and I would go back and say, "Until the entire BOM is complete, I'm not paying for anything, and you've got penalties associated with the entire invoice, not just a couple cables."
Oh yeah, I'm just thinking of how that supplier scorecard is going to shake down. So if we take this to now, we've made it to the factory floor. One of the articles that you shared with us in preparation for this estimated that collaborative robots or cobots would account for about 30% of total robotics by 2027, which is now, not all that far in the future. I'm curious if you think we're there already, and then if in order for these robots to be sensitive enough for handling different materials, for working alongside humans, how fiber optics is used in sensors that really accelerate this sensitivity. So I'm curious if you could expound a little bit on that, both from the 30% perspective and then how fiber optics are making robots, more sensitive and allow them to be more intelligent.
Okay, I'd be happy to. So I would be surprised if we haven't already reached that 30% mark, because I see robots with sensing capabilities in use every day in any number of ways. And in fact, I just watched this really great video on YouTube last week about how the Lamy fountain pen company in Germany is using robots in their highly automated factory, which is really wonderful. And most of them are using sensing, which integrates fiber optic capabilities to some degree. And so they're sensing the position of all of these parts. They're used for accounting, just any number of different automated processes. And this is for a fountain pen company, but it is in Germany, and that makes a big difference, I think.
The originators of Industry 4.0.
Exactly,
Yes.
exactly. So I think the food and beverage industry is also a market for this this type of incorporation of collaborative robotics, as is aerospace and defense. And then there are all types of industries that are considered to have some degree of hazardous duties. So anything that's dealing with sharp tools or blades, chemicals, cramped or uncomfortable spaces or conditions, any of those, I think, would be good candidates for collaborative robotics. Because if the process is highly repeatable, then it might be one that would be good to consider automation, especially if you want to gather some type of data about the process.
Mm-hmm. Yeah, it's really interesting to think about that. I mean, not only is it, what humans put forth that's really, really valuable is our time. And of course, we have a lot of expertise and can learn and provide feedback in a way that cobots might not yet be able to do. But I'm trying to regain my train of thought. But but for those repetitive tasks that are really, like low value generation, it's really handy to have a robot to take over that. And then consistency as well is one thing. So I think one of the articles that you shared, it mentioned having, because fiber optics are so thin, you could implement them into the skin of a robot cover that can sense pressure. So it would be able to sense the ripeness of a tomato with maybe a gentleness and delicateness that, human hands are really good at, but maybe that's not the best use of a human's time. And there's other more value added tasks that you could do for that. Or the ripeness of an avocado, which is everyone's, bane when trying to decide whether or not they're ready to eat an avocado. So I just wanted to kind of bring that, the why the fiber optics, can help with that kind of to the audience, in the article that you had shared with us. So, yeah, it's really, yeah. Go ahead, Carol.
I also add, yes, a lot of these things are also really good for integrating safety into the factory floor, where areas that may have been influencing the safety of the operators, and now these applications can or cobots can keep their jobs. They'll still have their job, but it'll make their job safer and maybe easier. So the use cases, applications of this are endless, and I agreed with the article that there is, and with you, Angela, as well, that there is still a lot more to come from this, and it's pretty exciting, actually, the topic of cobots. But you also mentioned the manufacturing processes as well. And so we've gone from the theoretical topic of fiber optics and optics, and moved all the way along to installation and contractual to the factory floor. And I'd like to stop or end off in the area of processes. And from my research, it was mentioned frequently that fiber is viewed to have a positive impact on manufacturing processes efficiency. And I wanted to know where you saw the opportunities there.
Okay, so it's my belief that using fiber optics in the manufacturing to connect the machines and the devices with data gathering systems will drive efficiency. Because today we know that if we could only see the data, we could improve so many different areas in our factory. So, for example, are the processes in control? Well, we don't know because we haven't gathered that information. But if we had this data, we could present it, or we could gather the data using fiber optics and these devices to gather it for us automatically, and then present it in some type of dashboard. And then we would know if the processes are out of control. And if they are out of control, we could take some type of action. And that would improve not only the efficiency of the process, but it would improve quality for the end product and thus our customer satisfaction. And isn't that what we ultimately want? So I think that it would also give us information that we could use to make repairs on a machine before that machine went down, and then that cost us costly production time. We could receive some type of alert that it was time for some sort of routine maintenance after X number of cycles or outputs, instead of just trying to guess how many times has this press been cycled. We could also keep better inventory. That would provide us with better numbers for demand planning, and we could even get better input on design changes. So if, for example, because of the data that we're getting from the factory floor, if that were automatically fed to our engineering teams, that some widget is kicking out every fifth time in the production floor because of some variable, they could make some sort of design changes which could reduce rejection rates or somehow improve the design overall. So I think that there's a lot of room for improvements based on the data gathered from the factory floor.
Thanks, Angela. I completely agree. Someone working in the connected tech space, we see this on a day-to-day. So I'm curious for a lot. So, we're in a bell curve of Industry 4.0, where some companies are really at the forefront and they've done a fantastic job of, upgrading their infrastructure and being ready to handle the immense amounts of data that is coming out of their factory, because data is the new oil. So it's really where you're going to get a lot of value. It's where you're going to make those incremental improvements. What do you see as like the first step that manufacturers that are still maybe operating in Industry 3.0 need to take to kind of come into or make sure that they have the backbone that they need for Industry 4.0?
I think they first have to understand what the processes are. Mm-hmm. So what are the processes today, and where can they begin to implement some of these changes that Industry 4.0 is going or will bring? Mm-hmm. And then begin to take the steps to bring them to that point. So what are going to be the big hitters? What are the first things? Those.
Yeah, I suppose like where you're,
yeah,
what's the low hanging fruit of,
exactly.
What's gonna, maybe what's causing me the most pain, and by resolving this, with new technology and digital tech, can we kind of resolve that? And then, what bandwidth and data processing power is required to tackle that? Would that be fair?
Yes, and who can be your early adopters, and who in your company can be a champion?
Yeah, I think that's another critical part of the equation. I think that would be, that's where the whole other discussion, which we wouldn't have time for today, but you're correct. How do you get people to adopt it internally so that it is used and not rejected as a change that's too difficult potentially to implement now, and people with the foresight and, that see the possibility of that future.
Mm-hmm.
Yes. Awesome.
Thanks, Angela. One of our with a bit about 10 minutes left to go, one of our I guess traditions, I guess, Grace, that we have at the end of a room. Did you want to?
Oh, the go around and
Yeah.
Yes. Okay. The round robin style. Go around and kind of present some takeaways from the discussion. And I think mine really come down to, a lot of this infrastructure is invisible. So, it's underground. It's not something that we come across so much in the day to day. Like, yes, I'm hanging out with my cell phone that does have 5G capabilities now because I upgraded recently. Like it's starting to show up in our lives in different ways, but then connecting the dots and then really understanding the implications for the different areas of life, whether that's, business and manufacturing, government, or consumer, and how it all interconnects with each other. I get that's just really where I started connecting a lot of dots and was really curious to learn more about fiber. So thank you very much for, bringing this to our attention and for sharing your knowledge and experience with everyone. I think, in new industrial revolutions come about when we have, on one hand, it's new technology, on the other, it's new sources of energy. So we're thinking like we have a lot of digital technology, and now we really have a lot of renewable power that's going to help fuel that digital technology that is power hungry. But then the piece that really connects it all together was fiber, and that was kind of the piece that I was missing prior to this discussion. So I do really want to share my sincere thanks for joining us today. So that's really my takeaway from today.
Thanks for sharing, Grace. I think the one story, Angela, you when we first met, you shared the story about the fiber set lay down in Chicago and the contractual issues, and I really didn't quite have a perspective of the enormity of a project like that and the number of people that are involved, from the suppliers to the component suppliers to the client, services client, and then the city of Chicago and probably the city workers, and it's just enormous. And I appreciate anyone who has to project manage a project like that. So that's one of those roles that would be would take someone with specific talent to. Did you have any? Well, we're including you in our last comments. Did you have any comments that or takeaways that you'd like to leave everyone with today?
Oh, this has been such a pleasure, and I'm so glad to have the opportunity to speak to you and your audience. One last final story I'd like to share is while I was with Wiltel, we built a fiber optic network along the southeast sort of coast from Houston to Washington, D.C. And as a part of building that network, we covered, or we went through what was a protected habitat. So we had to all have training to identify the habitat of the gopher tortoise. So that's another thing that you may not think about, but when you are laying a new network, or you're trenching to lay a fiber optic network, you're in all sorts of terrains, and it can include the habitats of protected species, and your workforce has to be cognizant of that. So I actually have a certificate that I have completed the training for the identification of the habitat of the gopher tortoise.
What are some of the telltale
certified.
signs that you've run across? So for anyone who's joining us from the Southeast, what would be like a telltale sign that you still remember on how to identify that habitat?
That's been like 20 years ago. So
All right.
I think it had something to do with like, disturbances in the ground.
Yeah. Well, who knew that laying fiber optic, I'm just, comparing like laying fiber optic cable, through things that I wouldn't have considered prior to this discussion of protected habitat too, reminds me of kind of the classic example of, putting down a new metro line in Rome is that you have to have archaeologists on the job at all times to uncover any historical artifacts. And
Exactly.
yeah, I can imagine needs for that potentially as well, depending on where you're laying cable in the US. So thank you for bringing that to our attention. Yeah, it's when worlds collide, there's a lot to consider. So speaking of like our physical infrastructure and, protected environments or just like the lived world that we're all in.
Exactly.
Yeah.
Yes, that's a great note to end off on. By including a note on sustainability of our environments. So I think we can finish off there. Before we close, I'd like to thank you, Angela, for joining the Industry 4.0 Club on this topic of fiber optics and Industry 4.0. Your knowledge and experience are valuable, and we really appreciate your continued interest and educating people on these things. It's really, really great as well when you include manufacturing, and it's very helpful for us. And a few housekeeping notes. If you like conversations like this, look out for more LinkedIn Live shows and updates. For updates and notifications, we encourage you to follow the Industry 4.0 Club on LinkedIn. And we also welcome you to join us on the Clubhouse app. We have rooms Monday to Thursday starting at 12:30 p.m., except Wednesday our fireside chat starts at 11:30 a.m. And I wish you all a great rest of your day.
Yes, thank you. And for anyone who enjoyed this conversation, please do connect with us on LinkedIn. We'd love to carry this forward. And Angela, thank you so much for joining us today. We really appreciate your time.
Thank you both so very much.
Thank you.
It was a pleasure. Thanks, guys. Have a wonderful rest of your Monday.